Welcome. Binary search sorts an array for a particular value and it then cuts it in half, and it repeats that process until the value is found, or if the value is not found, it returns nil. And I'm going to show you a detailed description of that in the third slide. So the O log n algorithm, or the logarithmic function, basically the distance doubles as time goes on. So if you see the blue lines, which is the distance, you'll see that it doubles as the green line extends out or up. And that is the O log n algorithm. So for binary search, we have an array of 19 values or 18 parameters, because 2 starts at the 0 parameter point, where 67, that is the endpoint of the array, and the 18th position as a parameter. So in the binary search, the search searches for the median or the mid value in the array, which in this case is 29. So it then logically looks at the value, which is 43. So we know that 29 is less than the value of 43. So it would do away with that value and all of the values in front, and it would start the process all over again. So now it's searching for the mid or median value, or the median in this array, which is 47. Checks the key value 43, which is less than 47. So we know that 53, 59, 61, and 67 is not a logical part of the search, including the median, which is 47. So we do away with that. Now we have an even amount of parameters in the array, and when it's an even amount, it splits it in the middle minus 1. So we're at 37, which is less than the value that we're looking for. So we can do away with 37 and 31. Now we are down to 2 parameters in the array, and we see that it is 43. So let's say, for an example, the key value was 44. The process would still be the same outcome up until the last 2 parameters. And in this case, if it were 44, then instead of seeing 43 there at the bottom, you would see nil. But because 43 is there, it shows 43, which would show whatever position that is in the array as a parameter. So starting from 0, which 2 would be 0, over to 43 in the top array, you would count the 13, and this would give a result of 13. So let's see how that would look in the playground to prove this algorithm. So the first thing we need to do is create a generic function for the binary search. Next, we'll search for the key in the left half of the array, then the right half of the array. Now we can create a constant array called numbers and get the key value. And as you can see, the result we get is 13, while the key value, 43, is the 14th value in the array. It is the 13th parameter in the array, with 2 being the 0 parameter. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So that is going to conclude this lesson on the binary search algorithm. See you next lecture.